All right, so talking about this idea of slope, we already mentioned before that the concept of slope is the same thing as what? What did we learn in our functions unit? Another way of saying slope is to call it, say it louder, Alicia. The rate of change, the constant rate of change. Constant rate of change and slope are that same idea, same concept. When we talk about slope, slope is basically just a ratio of what we call the rise over the run. Okay, and the rise values, that's that change of your y. The rise is your change of your y values. And then the x was the change, or the run is the change of the x values. So that's why we say the constant rate of change and the slope are same terminology. Just they represent the same thing. They're just called different things. So it's also known as the constant rate of change. Okay. Now, when we talk about it in equation form, which is what we'll be doing most likely tomorrow, getting into slope-intercept form, we'll have a variable representation for it as well. So for our slope, like we said before, it's going to be the rise over the run. And slope is mainly, like I told you guys before, slope is mainly going to be written in fraction form. So it's completely okay if you have it as an improper fraction. Do not sit there and try converting them into decimal format. Don't put them into mixed number format. Just leave them as a fraction, either proper or improper. And the reason why we want to do so, we want them in that format, is because slope is really, it's just a direction. It's a direction that tells you how to get from one point to the next point when you're graphing points on the line. So slope is a direction from one point to the next. Okay, so we're going to do just a couple of little problems, some that are like real world situations, a couple of graphs, a couple of tables, and then the slope formula is what we'll end up today with. So real world situations for slope. How many of you used treadmill before? Right, in gym class, sometimes they have them. On there, they have you can have an incline level, right? Yeah, that's slope. That is slope. So if you've got a treadmill, and the treadmill is going to extend from the backside of the ramp to the base of the machine, it extends 30 inches. With an 18-inch incline, meaning it's 18 inches tilted up. So I want to know, what is the slope? So in these situations, you just have to identify which one's the rise and which one's the run. So I'm not very good at drawing a little treadmill, but here's my little concept or idea of the treadmill. Yeah, it's a treadmill, okay? Gosh, whatevs. That's my treadmill. Get over it. What value is going to go right here? What value is this? Is it 30 or 18? 18. And then the treadmill extends 30 inches. So that extended out, it's extending out 30 inches. So it's going to go here. Okay, so that means that the rise of my treadmill, the rise is going to be that 18. And the run is going to be the 30. God bless you. And then, of course, like always, you need to simplify. What's 18 and 30 both divisible by?
2.
What else?
33.
What else?
4.
Not 4. 6. Okay, 6 happens to be the largest factor that can go into it. So 18 divided by 6 is going to give you 3. 30 divided by 6 is going to give you 5. So we have a slope of 3/5. That's it. Try this one on your own. You can tell me what they got for the slope, Alicia? 3/50. Good. So our rise in this case, right here, rise is 6 feet. Our run is going to be that 100 feet. So horizontal change of 100 feet. So the run's 100. And then what are they both divisible by? 2. Largest factor that can divide into both of them equally is going to be a 2. So that gives us 3/50 for our final answer. Any questions? All right, go ahead and turn to page 41 where the graph paper is. All right. When you are finding the slope on a graph, a lot of times they're just going to give you a line. So for right now, don't worry about drawing the line because you don't even know where it is perfectly until you know what the points are. And that's the thing. Sometimes they might already pre-draw points on there. Other times they might just give the line and you have to identify the points. Now to identify points on a line, grid marks. You're wanting to look for the point that the line passes perfectly in the center or at that crosshair where the grid marks intersect. So that's your job, is to look through there. So for example, here, right at this bottom point right here, that is a perfect point. So I'm going to go ahead and draw a point there. And that, I believe, is at -6, -4. So I'll even write that this is -6, -4. Then I'm going to follow the line up until I hit another one, which would be right here. What is that point at? -2, -1. If you can tell me the next point that it goes perfectly to. Ethan? 2, 2, right here. And the next point that it would go perfectly through. So just following it up until I hit this point right here, which happens to be at a +6 and a +5. Okay, so these all happen to be points that are on my line. What I need to now do is identify the slope, which is the rise from one point to the next point. It does not matter if I go from here to here, or from here to my third point, or from my first point all the way to my fourth point. It doesn't matter, because they will all simplify to the exact same thing. Slope is the same no matter which 2 points on the line you choose. It does not matter. So for example, I'm going to go ahead and go from the first point to the second point. What's my rise? How far up am I going to have to go? Not 4. 3 spots up. 1, 2, 3. And because I'm going up, what kind of value do you think that is? A positive. It is a positive 3. Now I want to go to the next point, or go to the, for my X, my run. How far am I going to move for my run? Go to the bathroom. How far am I going to go to my run? Count it. 1, 2, 3, 4. And I move to the right. Do you think that's positive or negative? Positive. So that's a positive 4. So what this is indicating here is that I have a rise of a positive 3 and a run of a positive 4. And that's simplified. Now, let's say that I decide, hey, I'm going to go from my second point to my fourth point. It's still going to give me 3 over 4, just not in a simplified format. To go from my second point to my last point, instead of going up 3, I would actually be going up 1, 2, 3, 4, 5, 6 spots. That would be a positive 6. And to go from the second point to the last point, I'd have a run of 1, 2, 3, 4, 5, 6, 7, 8. A positive 8. But that is the exact same thing. 6 over 8 is the same thing. It's just not simplified. But we know that we can divide this by 2 and divide this one by 2. It'll give us 3/4. Okay? So again, it does not matter which points you decide to check your slope with. Just pick any 2 points that are perfect points on the line and find the slope from there. How far did you rise? How far did you run? Now, just to keep in mind, if you are going up, that is a positive y, a positive rise. If you go down, that's a negative rise. If you go to the right, that is a positive run. And if you go to the left, that's a negative run. Everybody understand that? Because if you put down that it's a negative answer and it's supposed to be positive, or vice versa, you will get the wrong answer. Let's take a look at another example. Thank you. Thank you. Again, only have to pick 2 points on here. I only have to pick 2 points on here to be able to find the slope. Who can tell me one of the points that's on here? So I'm going to zoom in for a second so that way you guys can see a little easier. Tell me one point that's a perfect crosshair on here. Connor? Positive 1, positive 2. That is a perfect point. Now I just need to pick one more point on here. Somebody tell me another point. Justin. -1, +5. Very good. That's right here. That's at a -1 and a +5. Okay, so I just needed those 2 points. Now again, we read the graph from left to right, so I'm going to start with this point, and my rise, is it going to go up or down? Down. It has to go down to get to the next point, which is a negative rise. It's a negative rise. 1, 2, 3 spots to get down to that level. So it's a negative rise of 3. And then the run, I'm going to be going to the right. So is that negative or positive? Positive. And I'm going to move how much? 2. 1, 2. A +2. So if I have a -3 over a +2, that's just a -3/2. Any questions? All right, let's go ahead and go on to another one. Automatically from the video, you should be able to tell me what kind of slope this is. 0 slope, right? The flat horizontal line is 0 slope. Here's the reason why it's 0 slope. Again, I can pick any 2 points on here, so maybe I'll pick the points -2, +3, and I'll pick the point a +2 and +3. So first thing I need to identify is my rise. Do I have a rise to get from this point to this point? Am I going up or down? No. I'm not moving upward. I'm not moving downward. So that means my rise is what value? 0. My rise, because there is no rise, there's no rise, that means it's a value of 0 for the rise in your numerator. Now the run, because I picked these 2 points, currently my run is 1, 2, 3, 4. I moved over 4 spots for my run. But I could also say I can move 1 spot. I can move 7 spots. I can move 20,000 spots. It doesn't matter how much my run is, because of the fact that my rise is 0. 0 over any non-zero number is going to give you a 0 for your answer. If you check it out in your calculator, take your calculator and you do 0 over some number. Doesn't matter which number you do as long as it's not 0. 0 over any non-zero number. And then hit enter. You'll get 0, won't you? Okay? It's 0 on the top and then a non-zero number on the bottom. You should get 0. Yes, dear. Well, a fraction can also, like 3 can technically be a fraction. It's 3 over 1. Okay, so what we mean by don't put it as a decimal, don't put it as a mixed number. Okay, whole numbers are okay though. All right, example number 6. Same, similar type of concept. The vertical line is what kind of slope? Undefined. Vertical line has an undefined slope. Again, I could pick any 2 points I want. Maybe I'll pick the point 1, 2, and 1, 1. And right now I have a rise of -1. I have a rise of -1, but I don't have a run. There is no run, which means I get 0 for my denominator. And if I get 0 for my denominator, it doesn't matter what my numerator is. If I have 0 in the denominator, that's going to give me an undefined value. It's going to give you an error, right? Because you cannot have 0 for a denominator. Your denominator has to be a non-zero number. So if you come across a vertical line where there is no run, you're not having to move left or right to get to the next point. That gives you an undefined solution or an undefined slope. Any questions? All right, go on to page 42. We'll do 2 quick little examples once again from finding slope of a table, which shouldn't be that difficult because you already know how to do it because you did it in the last unit as constant rate of change, and they're the same thing. Change of y over change of x. But real quick, just a fast little reminder of the 4 types of slopes from our video that we saw. Okay, so when we had a slope or a line moving in this direction, what kind of slope was that? Positive. Right, puff, puff, positive. When it went downward from left to right, that was our nice negative. When it was the horizontal flat line, that was 0 fun. So 0 slope, 0 fun. And then our vertical line, worst words to say in math, undefined. Okay, so those are just again so you have a visualization of what the types of slopes are. Okay, so finding slopes with a table. So you know how to find it from a table, because if I told you find constant rate of change from a table, you knew to check the change of y over the change of x. That's just slope. So instead of calling it change of y, we're going to call it the rise. Instead of calling it change of x, we're going to call it the run. So what's my rise here for the y? Connor? -3. Every single time I'm decreasing by 3. So my rise in this case is going to be a -3. What's my run? A +2. Every single time I'm increasing by 2. So my run is a +2. So can't simplify that, so your final answer is just a -3/2. Now remember, we also talked about how sometimes it's not a consistent change, but they are proportional to each other. So you want to make sure that you understand that just because it's not the same rate of change all the time, that it might be a proportional value, which means it's an equivalent format. So here I've got my x values of -6, -2, 6, and 10. Those are my domain values. My range values or y's are -2, -1, 1, and 2. So for my rise, -2 to -1 is an increase of 1, but -1 to +1 is an increase by 2, and then +1 to +2 is an increase by 1. So these aren't consistent. I'm increasing by 1, then increasing by 2, then increasing by 1 again. So then we check it with the run. To go from -6 to -2, that's an increase of 4. But -2 to +6 is an increase of 8. And +6 to +10 is an increase of 4. So all we have to do now is check to see, are these equivalent formats? So I've got two different types of rises. I have a rise of 1 and a rise of 2. Bless you. I have two different runs. When I had a rise of 1, I had a run of 4 in both situations. And when I had a run of 2, a rise of 2, I had a run of 8. Are these equivalent to each other? Yes, they are equal to each other. They both simplify to the fraction 1/4. So that means your slope is just 1/4. I don't need to do too many examples of these. We've already done so much of them in our functions unit. The last thing I want to show you guys, though, is the slope formula. So sometimes you might have a graph, sometimes you might have a table, sometimes you might even have an equation, but other times they might just give you 2 points, no graph paper, and you just have to find the slope. So you can use the slope formula, and the slope formula indicates that you have 2 points. So we have x1, y1, our first point. And then we have x2 and y2. That's our second point. And then the formula is to take y2 and subtract y1 over x2 minus x1. And the order that you subtract does matter because it will determine whether you get a positive or negative result. So let's take a look. If I have the points 1, 2, and -4, 3, those are my points. Does it matter which one I assign as my first and which one's my second? No. Doesn't matter which one I assign, as long as whatever I do, I stick with that consistently throughout the entire problem. Typically speaking, my x1, y1, I usually just say it's my first point. Okay, so I'm just going to go ahead and label, this is my x1, this is my y1. That means that -4, 3 is going to be my x2 and my y2. So then you just have the formula that you're subtracting the y's and subtracting the x's. So please keep in mind, subtraction is not the same thing as your negative sign. So you do not want to inadvertently forget a negative sign just because you see the subtraction. So I usually like to set it up first. I put a fraction bar and a minus sign on both the top and the bottom. Then I fill in my numbers. Y2 is a 3. Y1 is a 2. My x2 is a -4. My x1 is a +1. And then I subtract. What's 3 minus 2? 1. What's -4 minus 1? -5. So my final answer is a -1/5. A -1/5. I always like to put the negative, if I have a negative on one of them, and only one of them, I pull the negative and put it in the front. Now if I have double negatives, what would that make it? A positive. Good. Go ahead and try this one on your own. All right, who can tell me what they got? Kinston? 1/2. Very good. Okay, so if we just assign these, we'll say that this is my x1, this is my y1. The -3, -2 is going to be my x2 and my y2. And then it's just a subtraction problem. Once again, you set it up as a fraction with subtraction on the numerator and the denominator. So you're going to take your y2 value, which is a -2, and subtract your y1 value, which is a -4. So you now have -2 minus -4. Then you take your -3 for your x2 and subtract your -7 for your x1. So you have -3 minus -7. -2 minus -4 is going to give you a +2. And then -3 minus -7 is going to give you a +4. And you can simplify that to 1/2. That's it. All right, tonight, and starting today actually, but today and then tonight, if you don't finish it for homework, then you need to finish it for homework. You have a quizzes activity on slope, so go ahead and get on.